Hello everyone, my name is Purvesh Borkar and my research topic is identification of sea debris using deep learning techniques. We will firstly try to understand the problem statement. Sea debris can be defined as human-caused litter which ends up into water bodies either accidentally or intentionally. Among those debris, the most common object includes aluminum tins, glasses, and plastic. As per National Geographic website, currently there are 5.25 trillion pieces of plastic in ocean. And as an impact of it, water quality has degraded. There are also economical losses for cleaning the ocean. And at the same time, this also leads to environmental and legal losses. There are two possible solutions to address the problem. Eitherly clean the ocean using human efforts, and the other way is to use autonomous underwater vehicle using image processing and machine learning techniques for waste identification and cleaning the ocean. Based on this, my research question is, does customly trained convolutional neural network model achieve greater accuracy than a pre-trained ImageNet-based model in detection of sea debris? This will help us in identification of underwater solid waste particles and assist autonomous bot in cleaning the ocean. Literature survey performed in order to achieve the research objective was divided into four parts. Firstly, we studied the details of underwater object detection. The technique for identification of underwater fish was first executed in year 2008. In 2012, the core limitation of low light in underwater was solved using color restoration algorithm. In the second part, we studied the object identification technique using manually handcrafted features in machine learning. This included machine learning techniques like support vector machine and shift feature extraction modeling. In the third section, we studied how deep learning algorithm is used for identification of underwater object. The study included mostly usage of convolutional neural network modeling for fish identification in aquatic environment. And lastly, we studied how transfer learning model can be used for sea debris identification. The study included survey of models like AlexNet and faster convolutional neural network. Based on the literature survey, we understood that there is a literature gap in the field of sea debris identification using machine learning. We intend to fulfill this research gap by building a deep machine learning model as presented in the upcoming slides. We can implement the solution using three techniques. Firstly, training the convolutional model using large annotated dataset. Secondly, using unsupervised technique for sea thresh identification. And lastly, making use of transfer learning model using deep learning. We will be using the third technique as it provides advantage of pre-trained features and using which we can use it in our algorithm. The challenges that we will need to look forward while building a deep learning model for object identification includes variation of light in the underwater. Second, free-flowing dirt and sand. And thirdly, freely moving seaweeds and plants. We decided to use YOLO version 3 transfer learning model for implementation of deep learning architecture along with the custom trained CNN model. The YOLO architecture was used because of the largely annotated dataset it is trained on and the performance timing. YOLO architecture is built on an image dataset of more than 330K images which are categorized among 80 objects, and its performance is 3 times faster than the SSD transfer learning model, which makes it the choice of our model. For training the convolutional model, we will be using a video dataset provided by Japan Agency of Marine Life and Technology. The dataset contains around 3,200 videos of sea debris of 8 different categories. The below diagram represents the architecture of proposed model. As discussed earlier, we shall be using a YOLO version 3 model for transfer learning. This pre-trained model contains feature weights of real-time objects of 80 different categories. These features will be transferred to our CNN model. After this, we intend to train the model using the video dataset of sea debris, which we discussed in the previous slide. We will be using data augmentation technique to solve the challenges that we discussed, like free-flowing dirt and low light in the underwater environment. Using image trajectory techniques, we will be solving the problems like overfitting in case of small dataset issue occurs. And in the last stage, the softmax classifier will help us in identifying the sea debris based on a probabilistic approach. The model performance can be evaluated based on the average recall, which is a measure to verify object identification ability, and based on the average precision, which defines the probability score of a classified output with relevant class. The implementation of research is in a crisp methodology format, which will include steps like business understanding, data preparation, then modeling, evaluation of the model, and at last the deployment of the model. And finally, we take a look at the licensing of the dataset that we intend to use for our research. The dataset is freely available for research usage and is permitted under the Copyright Act. Thank you for paying attention to the presentation.